Good morning.
Good morning, sir.
Shall we start this session now?
I think we should wait for another 2 minutes.
Shall we start this session?
Yes, sir, we
Am
can
I
start.
audible to you? Am I audible?
Yes, sir.
Okay. So let us start this session. Today we shall discuss the readily available J2EE frameworks for developing web applications. In last two sessions, we had discussed about how frameworks can be used for the purpose of developing web applications. Today, we shall discuss about three most important frameworks, their characteristics, their architecture, and the way of functioning. And we shall make a comparison between all these frameworks. First, we shall discuss about struts, then working procedure, how struts work. In the last session, we had also discussed something about struts. Today, we shall discuss some details about struts. Primarily, we are talking about struts 2. It is a MVC framework. MVC framework is based on model, view, and control architecture. The last two sessions we had discussed about MVC framework. The three primary components of MVC framework is model representing the data part, view representing the presentation part, and control representing the program logic part or business logic part. So in our web application, these three components must be there. So Struts architecture is based on these three components: model, view, and control. There are two suggested architectures: architecture 1 and architecture 2. Architecture 2 is, in real sense of term, architecture 2 is purely based on MVC. So before going to architecture 2, let us have some idea about architecture 1. As the diagram suggests, the one architecture 1 is purely based on JSP technology. In last sessions, we had elaborate discussions on servlet and JSP. The functionality of servlet and JSP remains the same. Only difference is JSP is easier to handle, easier to manage. It is easy for the developer to design the code according to JSP technology. Servlet is pure Java program. Ultimately, JSP gets translated into servlet behind the scene. So these are the two technology available for developing the programming logic, the business logic. Either you can use servlet or you can use JSP. It is easier for the developer to use JSP. Ultimately, behind the scene, JSP gets translated into servlet. So this architecture, the architecture 1 of Struts, that uses JSP. The developer has to develop the program logic, the business logic using JSP. So as the diagram indicates, controller and view, they reside in the same component, and model is represented by Java Win. Model means the data part. We need to write code for accessing the database. In an application, the code meant for accessing the database is model. So that code is called as Java Win. We need to develop a Java Win for accessing the database. So that Java Win represents a model. So view control is different from the model part. As we are using JSP, when anything is modified in the JSP page, so entire web application, no need to redeploy the web application. That is the advantage of JSP. In contrast to JSP, when anything is modified in servlet, there is a need of redeployment of web applications. But in this case, if anything is modified in the JSP page, there is no need for redeployment. So in this particular architecture, the model is different from view and controller. In real sense of term, this architecture, due to the presence of JSP, it provides a better separation of concern in which business logic and presentation logic are not mixed. So JSP provides a better separation of concern not to mix business logic and presentation logic. Redeployment is not required if JSP page is modified. So these are the advantages of number 1 architecture, model 1 architecture of Struts 2. In this architecture, that is purely based on MVC architecture. The client never sends request directly to the JSP, as in the case of Model 1 architecture. The diagram indicates that the client sends the request, that is represented by step number 1. The client sends the request directly to the JSP. So JSP receives the request. But in this case, in MCA architecture, the client doesn't send the request directly to the JSP. As the diagram indicates, the web container contains all the three components together: the controller, the JSP view, and the Java bin, that is model. The request is received. The architecture enables to perform authentication and authorization. Then a request is redirected to the view and model. The servlet directs the request to the view page for presentation. And the Java bin part representing the model that has the access to the database. So in clear terminology, in clear terms, this architecture is a MVC architecture. You can compare these two architectures. It is clearly evident that this architecture is, in real sense of term, the MVC architecture. In the last session, the working procedure of struts, we had already discussed in the last session how struts work. Now, Spring MVC. This is another framework. This is another framework available for developing web applications. Then Spring Boot. This is the third framework available for developing web applications. Spring MVC and Spring Boot. These are the two variations of Spring framework. So apart from struts, Spring has these two variations, MVC and Boot. Spring MVC and Spring Boot. So let us have a comparison between Spring MVC and Spring Boot, between Spring and struts. So among the available frameworks, let us have comparison between all these frameworks. This is Hibernate framework. So Hibernate framework is different from other frameworks in the sense that this is a specific purpose framework. Hibernate is a specific purpose framework. The objective of this framework is it is used for the purpose of object relational mapping, ORM. Other frameworks like struts, Spring MVC, Spring Boot, they are all used for the purpose of developing applications. And this is specifically, Hibernate is specifically meant for performing object relational mapping. So let us have a comparison. Struts and Spring. This is the table which gives the comparison between struts and Spring. Struts is a open source framework. Spring is also open source. They are readily available to you. Both are open source. But the difference is Strut is MVC framework, and it is based on servlet API. Whereas Spring, there are many variations of Spring. This Spring implements whatever the variation may be, whether it is MVC or it is Spring Boot. It implements inversion control and dependency injection, which is not there in Struts. We had some discussion in the last sessions about dependency injection and inversion of control. Inversion of control is the principle. Inversion of control is the principle that gets implemented through dependency injunction. So inversion of control is a principle that is implemented through dependency injunction. So what is inversion of control? It is the principle where the control of program execution is transferred from program's component to an external entity, such as the framework or the container. So as the name indicates, the application doesn't create its dependencies. Dependencies are injected. So this leads to more flexible and loosely coupled code. The code is not tightly coupled. The code is loosely coupled because dependencies are injected as and when required. They are not always associated with the code. As and when required, they are injected. And they are injected into the application generally through the constructors. You might be knowing what constructors are. Generally, constructors are used for the purpose of dependency injection. So these are the two basic characteristics. Inversion of control, that is a design principle. That principle is implemented through dependency injection. So Spring is a lightweight framework and Struts is heavyweight. Spring is lightweight framework. Lightweight framework matlab, it is characterized by minimum resource requirements. With the requirement of minimum resource, the framework works. So lightweight framework is a software framework that is characterized by a minimal resource footprint. It needs a small code base. It needs few dependencies. It needs less integration overhead. So due to these characteristics, the Spring framework is lightweight. On the other hand, Strut framework is heavyweight. And Spring is a layered architecture. The architecture is systematically designed by different layers. Primarily, there are three layers: presentation layer, then at the bottom, database layer, and middle is controller layer. The web controller sits in between. the presentation layer and the database layer. We try to recollect. In the first session, the general architecture of Spring framework has been discussed. That was a layered architecture with 5 layers. The middle layer is divided into 2. So this is a layered architecture and it is loosely coupled due to dependence injection. Due to the feature of dependence injection, Spring is loosely coupled. And Spring provides easy integration with ORM and JDBC technology. Hibernate can be easily integrated with Spring for the purpose of performing ORM, object relational mapping. And for database connectivity, we can use JDBC technology with Spring. So easy integration is possible with Spring. But for integration of these components with struts, we need coding. Manual coding is required. So these are the primary difference between struts and Spring. Similarly, Spring Boot and Spring MVC. Spring Boot and Spring MVC. These are the two variations of Spring. The primary difference lies in configuration. Spring MVC requires a lot of configuration. But Spring Boot, it supports auto configuration. In Spring Boot, the configuration parameters are set automatically, whatever is required. But Spring MVC, it needs a lot of configuration. Some components are there which are used with Spring Boot. Spring Boot provides many starters. We shall discuss what exactly starters are. Generally, starter is a unit of related dependencies wrapped together. What are the dependencies we need to use? They are represented by starters. So we can include many starters in the Spring Boot. So dependencies can be used with the web application using available starters. Starters are ready-made, readily available components. Dependencies can be included in the web application using starters. So Spring Boot provides the support of many starters. Whereas in MVC, dependency management is a top process. The concept of starters are not there. As it needs a lot of configuration in case of Spring MVC. So the development process is slow. But in case of Spring Boot, the development process is easier and faster. Another important thing is Spring Boot supports embedded servers. In Spring Boot framework, server is available as embedded component with the framework. With the framework, server is available as an embedded component. So it supports embedded servers. Spring Boot supports many production ready features. Some components are there with Spring Boot. They are known as actuators. So like starters, some other type of components are also there. They are called as actuators. So actuators represents the features which are called as production ready features. So like actuators, no such components are available with Spring MVC. We shall discuss what is actuator, what is server, all those things are to be discussed in latter part of our session. So these are the differences between Spring Boot and Spring MVC. Another important difference is Spring MVC is designed for the purpose of developing RESTful web services. That is not the case with Spring Boot. Apart from RESTful web services, other applications can also be designed using Spring Boot. So Spring Boot is very flexible and it can be used to build many different other applications, not only RESTful web services. Whereas Spring MVC is used for the purpose of developing RESTful web services. RESTful web services matlab the application which relies on the principles of request response model. A request must be sent by the client. The application receives the request and the request gets processed by the application. During processing, if required, database connectivity is made. A response gets generated and response is sent back to the client. These are the basic principles of request response model. So RESTful web services relies on the principles of request response model. The Spring MVC is primarily meant for designing dynamic web pages, whereas Spring Boot can be used to build many different other applications. So these are the differences between Spring Boot and Spring MVC. Now Spring and Hibernate. As I told you, the purpose of Hibernate is performing ORM, object relational mapping. So Hibernate is an ORM framework specialized in ORM operation. This is a specialized framework, Hibernate. Hibernate is a specialized framework. Spring is, as we discussed till now, primarily Spring is used for the purpose of developing enterprise Java applications. Whereas Hibernate can be integrated with other frameworks for the purpose of performing specific applications that is ORM, object relational mapping. We shall discuss the architecture of Hibernate in detail. Hibernate framework, it provides persistence, object relational persistence, and query service for applications. There is a language associated with Hibernate framework. The language is something similar to SQL, structure query language. You might be knowing what is SQL and what is the purpose of SQL. Like SQL, there is a language that is HQL. HQL stands for Hibernate Query Language. So Hibernate Query Language is used for the purpose of framing query that can be put to the database for retrieval of data and for storing of data. So database can be accessed and the database can be managed using HQL. That language is available in Hibernate framework. These are the characteristics of Hibernate. It provides data persistency. It is open source. The performance is high. It is lightweight framework. It is database independent. That means Hibernate works with any database, whether it is Oracle database or SQL database, whatever the database may be. Access database, whatever the database may be, the framework is independent of the database. It provides caching facility. So two levels of cachings is available, primary level and secondary level. It is scalable and it is having a language that is Hibernate Query Language, SQL. So these are the characteristics of Hibernate. With all these characteristics, it is used for the purpose of object relational mapping. We shall discuss the architecture of Hibernate in latter part of our session. So as far as Spring and Hibernate are concerned, Spring framework is completely meant for developing enterprise Java applications, whereas Hibernate is a specific purpose framework that can be integrated with Spring's like frameworks. That can be integrated with Springs, that can be integrated with Struts. Because Struts, Springs, they are all generalized frameworks meant for developing enterprise applications. So Hibernate is a specific purpose framework that can be integrated with any other frameworks. Now, we shall discuss some details about the MVC. Already we have discussed the features of MVC. Now we shall discuss the details about MVC. This Spring MVC is a primary framework and this is the inner mechanism on the basis of which the Spring MVC framework works. These are the components of Spring framework. There is a core container. The core container contains bins. It contains the component of expression language. It also contains the core component. Over this layer, there is another layer. That layer performs aspect-oriented programming. So as it contains aspect-oriented programming, this layer contains different aspects. This layer is also having a component which is known as instrumentation. And over that layer, there are two sublayers. Data access and data integration layer, that is consisting of transactions module, and that is integrated with JDBC, OXM, ORM and JMS. This ORM is performed by Hibernate. JDBC is meant for establishing connectivity. After connectivity is established, then ORM is performed. Then another sublayer is web layer. That is consisting of four modules: WebSocket module, Servlet module, Web module, and Portlet module. So these are the four layers of Spring framework. First is core container. As the diagram indicates, the core container contains four modules: bins module, core module, context module, and expression language. The module so this layer, primarily the core container, this layer performs two operations: IOC and dependency injection. IOC principle is implemented through dependency injection. In a object-oriented framework, one model may depend on another model. One object may depend upon another object. For example, car and engine. Car is an object and engine is another object. So engine object gets injected into the car object, and car object depends on engine object. Only when engine object gets injected into the car object, then car will become functional. In Spring framework, both the objects are separate entities, car object and engine object. They are not tightly coupled. As and when required, engine object gets injected into the car object. That's why they are loosely coupled. When the application needs, then it provides the facilities for injection of engine object into the car object so that car becomes functional. So that analogy can be used with this application.
Means they
When,
can't be run without each other.
sorry,
Means they can't be run with each other without each other.
you are not audible. What?
I'm audible right now.
Yes, yes.
I am saying they can't be functional without each other.
Without
each other
uh,
can't be functional.
please write your question in the message box. Can you write the question in the message box?
Okay. So then I wrote it.
Hmm. That is why dependency injection is done. They cannot be functional without each other. That is why dependency injection is done. But the thing is, as it is when it is required, at that point of time, dependency injection is done. So as and when it is required for injunction of engine into the car, then only it is done. So that is the reason why the principle, why it is called loosely coupled framework. They are not available always with each other. As and when required, one object gets injected into another object. Okay. So these are the two facilities, IOC and DI. These are the two features of the framework. These two features are implemented through core container. So core container, as the diagram suggests, the core container performs the inversion of control and dependency injunction. Then another module of the core container is beans. As you know, bean is a Java software component. Bean is a Java software component. So the Spring framework may be available with a bean factory. The bean factory helps in implementation of the factory design pattern. You might be try to remember that. So there are 4 design patterns. In the first session, we already discussed about the design patterns. Among the 4 design patterns, there was a design pattern, that is factory design pattern. So here that design pattern is implemented. So bean factory design pattern that comes under bean module, it helps in implementation of a factory pattern. That means interface is available. Common interface is available as a bean. From that interface, we can implement many classes. Suppose interest is a rate of interest is represented through an interface that is commonly available. From that interface, we can derive 3 classes. One class is meant for rate of interest for daily use accounts. Another class is meant for rate of interest applicable for recurring deposit accounts. Another class can be derived from that, which is meant for rate of interest applicable for fixed deposit accounts. So one common interface is available, that is rate of interest. From that common interface, 3 different classes can be derived. One for rate of interest for daily use accounts, savings accounts, another for rate of interest for recurring deposit account, third one is for rate of interest for fixed deposit account. So this is factory design pattern. So as per the requirement of the web application, so core container contains a bin factory. Bin factory matlab interfaces are available there. From the interface, we can derive many classes, multiple classes as per the requirement. Core and bin module provide strong base to build context module. So context module works as the focal point of application context. It represents the context of the application. Then comes the expression language, SPEL. Expression language is SP is Spring Expression Language. So expression language is for querying and manipulation of an object. So what exactly is an expression language? So expression language in this framework, it is used in this sense that it is a powerful non-procedural scripting language primarily used with this application. Its main purpose is to simplify access and manipulation of data stored in the database. So, expression language, the main purpose of expression language is to simplify access and manipulation. Access and manipulation of data. Data represented through various scopes and objects, including Java beans, lists, arrays, maps. So in a web application, data can be represented in many ways. Data can be represented through data objects. Data can be represented through bins. Data can be represented through maps. Data can be represented through lists. Data can be represented through arrays. So an array can hold data. A list can hold data. Java bean can hold data. These are all different objects. To access these data objects and to manipulate these data objects, the expression language is used. So expression language is a primary component of the core container. So just above the core container, there is another layer which is consisting of 4 modules. AOP. AOP stands for aspect-oriented programming. As it supports AOP, so many aspects can be there with this Spring framework. So what is aspect-oriented programming? Object-oriented programming and aspect-oriented programming. Object-oriented programming, everything is represented through objects. Aspect-oriented programming, it is a powerful mechanism and it helps in modularize. It helps in modularize the cross-cutting concerns in the application. So each concern is called as an aspect. Cross-cutting concern. For example, the aspect-oriented programming allows the programmer, allows the developer to separate the functionalities like logging, security, transaction management, caching. So all these modules, logging is a module using which we can log into the application. Security is a module. That module is exclusively responsible for managing security of the application. Transaction management. Transaction management is responsible for performing all transactions with the database. Caching. Caching is responsible for managing the cache. Cache is the memory that is available. During transactions, intermediate data can be stored into the cache. So caching is a mechanism. So all these operations, logging, security, transaction management, caching, etc., etc., all these operations can be represented through aspects. And the framework allows us to perform the management of all these aspects. That principle is known as aspect-oriented programming. So due to aspect-oriented programming, due to the available of aspects, the code becomes reusable and code becomes easily maintainable. Wherever there is a problem in any of these aspects, we can deal with the problem with that particular aspect only without affecting other components of the applications. So easy maintainability and reusability are ensured using due to the availability of this aspect oriented programming. So simply aspect is a module. Aspect is a module that encapsulate cross-cutting concerns. Technically, we can define aspects as it is a module that encapsulates, that contains cross-cutting concerns. The security aspect is different from logging aspect. Again, it is different from transaction management aspect. So all these aspects are different from each other. Due to these aspects, it becomes easier for the developer to ensure reusability and maintainability. So this layer contains the modules which is represented by AOP, and due to AOP,
So these layers
another
having
module is
some names or something, or these components are having
what?
just. I'm audible first of all.
हाँ.
I
Yes,
am
बोलिए.
saying that these layers are having some names or something we called like core container and
Spring is primarily MVC, based on MVC architecture. Okay, Spring is primarily MVC architecture. When you refer to the architecture that has been discussed in the session 1, the generalized architecture is there in session 1. We have already discussed about that architecture. This particular framework is based on that particular architecture. All these components can be differentiated, can be grouped into 3 categories: M, V, and C: model, view, and control.
yes, sir.
Okay. For example, the data access layer, which is depicted here, that belongs to the model category of that primary architecture.
Mm-hmm.
Similarly, control. These aspects, aspect-oriented programming, all these things, this instrumentation, all these components belongs to the controller part. Okay.
Okay,
So
sir.
primary architecture, the fundamentals architecture of the Spring, that is based on MVC principle, model view and controller principle.
Spring Boot matlab means whole framework is considering MVC.
Spring,
Spring framework.
Spring framework, that is primarily based on MVC, model
Oh,
view and control
okay, sir.
architecture. Then instrumentation. Instrumentation is another module that is available in the Spring framework. Actually, don't get confused. This is not the architectural diagram. This diagram depicts what are the modules available in the Spring framework and which module is responsible for what operations. That is what is depicted through this diagram. This is not the architectural diagram. This diagram depicts the modules available with the Spring framework and what is the purpose of the each module available with this framework. Okay, so instrumentation. Instrumentation, it is also refers to a mechanism. Instrumentation refers to a mechanism that allows for the modification in the Java bytecode at runtime. The modification of the Java bytecode at runtime. That means it enables the addition of instructions to a program to analyze its behavior without altering the original source code. I mean, during runtime, when the program is getting executed, when the program is running, at that point of time, during its execution, some changes, some modifications can be done, can be made. Why this modification is required? To analyze the behavior of the application. For
Uh,
example,
yes, sir.
this module is primarily used. This is primarily used for monitoring, for coverage analysis, and to some extent for debugging. These are the purposes for which these particular components may be used.
Sir means matlab modifications of the program can be made during runtime.
During runtime,
Runtime
yes, this module, the availability of this module in the framework, it allows you to do some modifications for the purpose of debugging, for the purpose of analyzing the behavior of the application. For that particular purpose only, you can make some modifications.
means if the application is not running as per the expectation of the developer, then we can do some changes so that it will run
Without affecting the main source code.
without affecting the main source code. Yes.
Main source code, yes, without affecting the main source code. That is the reason why it is performed at the runtime. Source code remains the same.
Okay, sir.
Then messaging. As the name indicates, messaging, this layer is responsible for generation of the message service. It performs, in one word, we can say that it does message service. it generates the message and it consumes the message. It consumes the message, this module, as well as it generates the message that can be meant for the client. Then at the top of these modules that belonged to core container, and these 4 modules, at the top of these 2, there are 2 sublayers with some modules, data access and web module. As the name indicate, data access layer contains the technology like JDBC. As you know, JDBC is Java database connectivity. It is responsible for establishing connectivity with the database which is at the bottom of the architecture, which is at the back end of the application. So fast connectivity is to be established with the database, then only we can perform transactions. So for establishing connectivity, JDBC technology is used. After JDBC connectivity is established, then ORM comes into the picture. Then Hibernate comes into the picture. Hibernate performs the object relational mapping. Database contains information which is relational in nature. Your application deals with the information in the form of objects. So they are 2 completely different entities. Object is a different entity. A relational database is another different entity. There is a mismatch. So to avoid this mismatch, to maintain compatibility, mapping is necessary. So information contained within the object is mapped to the relational aspect of the database. That mapping is done by ORM. That mapping is called ORM and it is done by Hibernate. So JDBC is meant for establishing connectivity. ORM is object relational mapping that is done by the Hibernate framework. Then object XML mapping is also required. Why it is required? Object XML mapping, OXM. This is required for the view purposes. This is required for the view purposes. Then JMS is required for Java messaging service. This part is used for the purpose of message production and consumption. Then transactions module. Transaction module helps in performing transactions. Here comes the usefulness of HQL or SQL, structured query language, or Hibernate query language. Framing queries and putting the query into the database so that framing the query